Okay, getting started with NumPy. What is NumPy? It is a fast mathematical computation library. Okay, the general purpose library available in general purpose the library available in Python is slow. Got it right? Okay, so this is the problem with general purpose. It will be relatively slower. Okay,
Okay.
and the next thing is NumPy is specialized for doing mathematical computation.
Okay.
Okay, specialized for doing mathematical computation. Okay, third aspect is, okay, it is internally implemented using C, so it is very fast.
Okay.
Implemented using C, so fast. In fact, for the matter of fact, entire machine learning is implemented using C. The wrapper is only Python.
Okay.
Okay. Okay, so now it can do hide.
Then why can't we write that code directly with the C language? What is that advantage of C, a wrapper of it?
Right. See, why is Python so super sexy at, it integrates with any component. Okay, generally wherever you see a product out in a market, you will definitely have Python interface to that, because Python makes it very easy to talk to other systems. Okay, Python is used in many stuffs as a gluing programming language. Yeah, like for example, if you see the example of Facebook, it uses Python basically to glue across different components. Okay. Okay, so what you do, I mean, it's a general, you will see a lot of software using this philosophy. Internally, they are using your C, because of course C is fast. Okay, the complex code is written in C, and whenever it has to interact with some other part of the system, they expose Python interface, and because C and Python can talk to each other with very low cost. Clear?
Okay.
Okay, fast. And what does NumPy also provide? Okay, NumPy provide high dimensional mathematical computation. Like you can do a 10 to the power 6 dimension matrix. I'm not talking about size. The 3-dimensional matrix is a cube. I'm talking about 10 to the power 6 dimension matrix multiplication. Okay, so those sort of things.
So what is it? 10? I mean, I didn't get you.
Yeah,
Your voice is breaking.
10 raised to the power 6 dimension.
Okay, got it.
Okay, what I'm talking about is 10 raised to the power 6 dimensional matrix operation can be done with ease with NumPy. Okay, so internally your all machine learning libraries will be using NumPy to implement various algorithms. High dimensional computation. Okay, these are some highlights of NumPy. Okay, let's first see how to create NumPy and how. Okay, so NumPy creation. NumPy. Okay, so one is we'll create from list, create zeros, create ones, will range random. So you have all these sort of options here. Okay, to create, let's first use one by one. So we want to create it from a list. Let's first create Python list. Okay, 1 2 3 4, some numbers in Python. Okay, now if you do it, then what I have to do, I have to import NumPy. Okay, import.
So what is the first one? Line 1. What are you doing there?
So creating a list. That is a Python data structure list. Okay. Okay, so what you're trying to do now, we are trying to show using the first method. Okay, creating list. So I'll actually rather delete it. Import NumPy as NP. Okay, this is importing NumPy library. Okay, then what you're doing, we are creating. Sorry, you're creating a list. L is equal to 1 2 3 4 5. Okay, so you're creating a list here. Now what you want to do, you want to create a numpy array from this list. List is a Python data structure. Okay, it can, so what you're doing here, we are trying to create a numpy data structure from a Python data structure. Okay. Okay, so if you do this, so it is, this n is a numpy data structure. If you do n dot and tab, okay, you'll see a lot of functions here available with numpy. This is not available with your regular Python data structure, right?
Yeah.
Okay, so this is the advanced computation library that is present here. Okay, this is first way of creating. Second way of creating is zeros. So what you do, np dot zeros, okay, and you pass here the size of the data, so 10 elements you want, and you can pass the data type. D type means data type. You want to use int, sorry, data type np dot, okay. So what it did here, it created a array of 10 zeros, right? As simple as this. Okay, you want
So this is an array. It's an array, right? Created.
Yeah, it's a numpy array.
Numpy array. Okay.
Okay, I'll keep them numbering. Okay, this is a numpy array. Similarly, we are creating more. This is what we are trying to do. We are trying to create numpy arrays. If you do np dot float, okay, if you do n3, it will show you the all the data is in float actually here, right? One dot. Fine, right? Okay, you have more general purpose function here, equal to np dot fill. Full, yeah, full, not fill. Okay, so right here 10, and right here the default value, say 111. So it will create a numpy array of 10 size with all value initialized with 111. Fine, right?
Okay.
Okay, so just data creation just became this easier, and you know, you have numpy has a lot of inbuilt utilities, okay, which is supposed to do a lot of things for you. Inbuilt utilities. Okay, now we'll see the next stuff. We will try to create range, right? Np.arrange, if you give 10 comma 100 separated by 5, so what will it do? It will generate you a list, generate you an array starting from 10, stopping at 100 separated by 5.
Okay.
Fine, right?
Yeah, correct. But is it arrange or a range? Not a range. It's
Arrange,
considered a range.
Arrange, yeah. Okay, arrange. So it is letting this one. Now,
One question, like why are we importing NumPy as NP? Why can't we just write NumPy? Sorry.
of course you can do that, but every time you have to write numpy.array, numpy.zeros, numpy.ones, entire thing.
Okay, so we can use NumPy as N also, right? So that is also possible.
This is just there is something de facto actually. So everybody does it. So good to do it. So nothing much. Nothing wrong about it.
Okay.
So here you are doing arrange to generate this data. Now you want to okay. So as of now, what you have seen is you're generating only one-dimensional data, is it?
Yes.
Okay, but of course this is not the limit. You can generate any dimension data. Like suppose you
like matrix,
like 3-dimensional stuff, whatever. So let me show. Suppose you do ones. Okay, so you want to generate a cube of 3x3 all initialized with 1. Okay. Okay, here size always will pass it like this.
Size, okay.
Okay, if you just do like this, it generated a matrix for you 3x3. Fine, right? I mean,
okay.
3x3 is your cube. That is, it is generating it's a 3-dimensional thing. It is not 2-dimensional, it's 3-dimensional, if you can notice.
Understood. Yeah, 3 equals 3 times.
Right. This is one 3x3. and you add one more thing to that. Okay.
So the first element will be the first matrix, second element will be second matrix, and third element will be third matrix.
Right.
Okay. And then is it possible to access first elements first? I mean, A11 like that. It's possible, right? We can access and we.
Yeah, I can show you right away.
Okay.
So if you want to access D1, right, you will access it. Fine, right?
What is it?
This is first element of first. This is the this is the centermost element, most element actually. This D1 will be giving you this matrix, the first row. From there, if you do 1, you'll get the middle row, and if you do the 1, you'll get the middle element. Fine, right?
Why it is middle? 1 means it should be the first row, right?
No, it starts with all zeros, right?
Oh, 0, 1. Okay.
Yeah, let me show you.
Okay.
This is your N2, right? N1. So if you do
And then in okay, understood. And 1 of 0 is okay. It's always start with 0.
Right. It always starts with 0, and it ends with. Okay, it ends with -1. Okay, of course. This is typical list syntax actually. This is also you access the same way.
So in that case, if I put n of 4, it should be 5 again, right?
Right.
In 1 of.
Right, absolutely.
Then what is the significance of putting a -1 there?
You don't have to know how many elements are there, isn't it?
Oh, okay. Got it.
This is Python syntax actually. In Python also you do the same thing. Okay. So
I mean, I'm not well versed with Python. That's what I was.
No. Feel free to ask. I'm just telling you the similarity. Okay.
Okay.
So I mean, you'll see the same thing in Python. Then you'll be able to correlate. Okay. Okay. So then you suppose you want to generate random numbers. Okay. This is quite useful here. Okay. np dot random. Okay. Dot rand. Okay, and you can mention the size here. What is the data size that you want? Suppose you want a 4x4 matrix. Okay. Then yeah. Size expect. So here yeah, so here what you're doing, you're giving it 10, so it generates 10 data of random numbers. Okay, and these numbers will be between 0 and 1. Okay, what you have other than this is rand int. Okay, rand int you can give the beginning of the stuff, you can give the ending of the stuff, I mean this range, and okay, this is the range, and you can tell the size. Suppose size you want, so 3x3. Okay, so all the numbers will be between 0 to 10 here, apparently between 0 and 9. 9 inclusive, 10 is exclusive. Understood, right?
Yeah.
So this hello.
Yeah.
Yeah, I'm online.
Okay. Hi Venkatesh. Hi. Oh, yeah. Nitish is also there. Okay. Okay. So yeah. I just hello.
Hello. Yeah, tell me.
Yeah. There was some.
Yeah. Hello.
Okay. So I just started. I'm recording the session. I just started with Numpy. Okay. Here these are the ways. First is by creating from an existing Python list, then creating from zeros, then creating from ones. Okay, then using full, it will create array of 10 elements, all the numbers initialized with 111. Okay. Then you have arrange to generate a sequence of numbers between 10 and 100 you're generating, and separated by 5. Okay, between 10 and 100 you're separating by 5. Okay, then you can see the series. After that, you have random. Okay, this is what you're doing. You're generating 10 random.rand. This random stuff you'll be using very often throughout. Okay, what you're doing this, your random.rand, it is generating you 10 random numbers between 0 and 1. Okay, by default, random means 0 and 1. How many numbers are possible between 0 and 1?
Yeah, 1 minute. Hello.
Yeah. How many numbers are possible between 0 and 1?
Okay, okay. ठीक है, ठीक है.
A lot.
A lot, right? Infinite, actually.
Yeah. Yes.
Okay, so that's what this case is. Okay, you have infinite possibilities of numbers between 0 and 1, as you see here. And now what are you doing? You are doing rand int. Okay, rand int means it will generate integer whole numbers, and you're telling him the limit. This is the start number, this is the end number, and the size of the data structure that will be generated out of here.
Okay.
Okay, this is 3 cross 3. Okay, so
Here one question. Hello.
Yeah.
See, instead of a matrix, if I want a list of this of 10 elements, so is it possible like that instead of matrix?
Yeah. For that, what you have to do is the same stuff. Okay, rand int. Just you want to make from 2 to 20. You want to generate suppose 100 numbers.
Okay, just put 100 there.
Yeah. Fine, right?
Okay.
Between 2 to 20,
correct.
it will generate 100 numbers. That's pretty much. Okay. Now, these are the basic ways by which you can create a NumPy data structure. Of course, you have a lot of other ways, but these are the basic ways. Now we'll try to access elements of a NumPy data structure. Okay. Accessing elements. Okay. First, let me create some data. NP arrange suppose it will generate data up to 10. Rather, I will use rand int in this case. Five cross 5. Okay, so data will be something like this. Okay, now suppose you have to access the first row. Okay, first row, this one, right? How do you access the first row? Data, right? You're accessing the first row. Fine. This is two-dimensional stuff, right? You're accessing the first row. Suppose you have to access the first element. How will you access?
0 0.
Right. Okay, this is accessing the first element. Suppose you have to access the access rows, first to second rows, first and second rows. How will you do that? You have something known as slicing. Okay, so here you write 2. That means 2 is exclusive. 0 and 1 rows will be starting to show up here. Fine, right?
Okay. Yes.
Clear?
Okay.
Yes.
Okay.
Can you please repeat this thing?
Yeah, so when you write :2, right, it means whenever you write index number here, right, it means data number 0, data number 0 and data number 1. What is data number 0? This highlighted one. What is data number 1? This highlighted one. Fine, right?
Okay.
Okay, so when you write :2, it means all the data before 2. Okay, so when you write data 2:, it means all the data after from 2.
Okay, it denotes from colon 2, right?
Right. First one from
okay.
2, this is 2 onwards all.
Okay.
Okay, I mean this means till 2, this means 2 onwards all. Okay, let's see now.
Access only columns. Can we access only column?
Of course. The answer to all this question should be yes. Okay. Of course, you can access column. How do you do? Suppose you want, I mean, for column, as of now, I'm just giving, I want all the rows. Okay. And you want column number 1. Fine.
Okay.
This is my column number 1, isn't it? 7, 15, 13, 4, 14.
Yes.
Okay.
Okay.
Okay. Now you want to access this. This is column 1. You want to access suppose column number 2 to 4. Okay, 1 to 4. So you can write like this. 1 2. This will access. Give you access to column number 1 to 1, 2, and 3. Fine, right?
Yeah.
Okay.
See, this is the data. This is
So
the,
we can.
Is it mandatory to put that colon there? We can just directly put
no.
comma and
Whenever you do this colon. Okay, so if you write here. Okay, it is of course a syntax error. But when you tell here only colon, it means all the rows. Okay, and if you want to print the entire stuff, entire array, you can do data colon comma colon.
Oh.
Okay, 1 to 4 means 1 2 3. 4 will be not included. 4 is not inclusive. Fine, is it clear?
Yes.
Yes.
Okay.
So
Okay.
So we can access any element in in a matrix, right?
Right, any element. Suppose you have to access, you have to get hold of this matrix 13, 17, 4, 11. How will you do that?
0, 1, 2, 2, and dot of 2, comma 6, I think.
So this is 13, 14, right?
2,
So this is 1, 2, 2, 3, right? So I'll write from 2 to 4.
12, 10, 12, yes, 2 to 11, 2, comma 11, right?
Yeah, yeah. So this guy 2 to 4, and this guy is these two rows, right? This is column number 1 to 1 and 2. So if I do this, I'm getting this, right? Fine.
Yeah.
Okay.
Can you show one example of that 3 by 3 by 3? That is the 3-dimensional, and access the middle one like this, the column and.
Okay. But that the problem with that, those things we cannot cross verify. Okay, because okay,
No,
let's
just to see how it works.
suppose we have a data. Oh, sorry. Suppose we have a data like this. Okay, and if you do data, you get again this stuff. Okay, 5 cross 5 cross 5 matrix. If you do data, suppose I want to access this element. Suppose I want to
999.
huh?
Yeah, I mean whatever.
This middle element, say. Okay, or say I want to access, yeah. So so I'm just 5 is out of bounds for x2 with size 5. Oh yeah, 5 is out of bound, right? 5 is the maximum dimension. So you can write 2. Okay, let's see what it prints now. So what did it? Can you tell me what is this?
Which one?
Actually, let me just make it simple. Let me write 333 so that you can imagine it as a cube. I can explain you the Rubik's cube. Okay. Okay. So now tell me, if I do this, I'm getting this. Okay. Tell me, how is this coming? Think of a Rubik's cube.
Actually, what happening is it is taking first column from each matrix.
First
Correct?
column.
Yeah, I mean 0, 17, 15, 17. Zeroth column is 17. First column is 15, and second column is 17. Index start from 0 to 3. 0. So what it is getting in a first list was first column, and second list first column, and third list first column.
Right. You imagine it with like this. Okay. Imagine it with like this. Okay. Okay. This is 3 layers. Okay. Now, this first row that you're seeing, right? This first row. Okay. Actually, to draw a cube. Okay. So now. Okay. Now this 15.5.4, right? 15.5.4. Okay. So 15.5.4 is here. Okay. Then you have 2.8.4. Fine, right? Then you have 8.13.13.
Yes.
Okay. Okay. So what you're doing here, you're chopping off the middle layer. Understood, right?
Yes.
You're chopping off the middle layer. This layer. This information will be in the middle, this part of it. Okay. Imagine these things kept. This layer is one layer, this layer is one layer, this layer is one layer. You have kept these layer one after another. Then you're cutting from the middle, slicing from the middle. That is what you guys doing. Clear?
Yes.
Understood by, you can understand by cross checking it, but just by applying the logic, can you tell me what all these comma indicators, first one, second one, and third one indicators? The last, that will be easy to understand more.
Right. The first one, right? This first colon. This tells you the sidewise information, the row wise information. The second column tells you the height wise information. I mean the y-axis. The third column tells you height wise. Okay. So here, if I give you 0, right, what will be the output?
17, 15, 3, 2.
Right. Because you are talking about height. This first layer, height of the layer. Okay. Now, okay. So let me show it first. Okay, 17, 15, 3, right? So now suppose if I keep the last layer this and I change the middle layer 1, what will be the output? Okay, this is your y-axis, right? Y-axis is, okay, y-axis is toward the flat direction. Okay, so you can see here, you're getting the middle layer, right? 15, 5, 3, the y-axis towards the y, 15, 5, 3, 14, 8, 3, right? 18, 3, 13, 12, the middle layer from this direction, right? From this direction. This is your y-axis. This is the middle axis. So also when you change the first element to 1, what will happen? What will be the output if you change the first element to 1?
And the rest of column?
Suppose you change it 1. First element, what will be the output?
The first element of the array.
17, 15, 17, 2, 2, 9, 5, 8, 19.
2, 2, 9, 5, 8. Exactly. Okay, wait. 17, 15, what are you getting? 2 to 9.
Yeah, the second element, because, 2
to 9, 14. Oh, right. So we are getting the, the face of the layer, right? This is your slice. Oh, sorry. I gave it 1, right? Actually. Yeah. This is okay. Yeah. This is, I think that's what you all said. I wanted to. This is the second element. Clear, right?
Yeah. Understood.
Yeah. Nitish and Venkatesh.
Yes.
Venkatesh?
Yeah, yes.
Yeah, right.
Getting.
Okay.
Yeah, getting the things.
Okay. So of course, if you add more dimension, it will be very difficult to map it through your mind. And the thing is, all these things will be done by the software. I mean, doing this complex thing, and it can hold 10 raised to the power 6 dimension. So it can do pretty complex things. Okay. Now I believe you have a decent understanding on the access part of it.
Yes.
Now, Okay. So as I was mentioning earlier, all those code and everything can be found in the notes here. Okay, you can download the introduction to Numpy. I'll of course be uploading this stuff. Okay, now and here okay, so all this code is available here. So now what we'll try to do, we'll try to understand shape of the objects. Okay, shape, size, and dimension. Okay, so one thing I think I haven't shown it, but one thing, all this NumPy data structure is mutable, so that means you can change the contents of it, right? Mutable. Everybody understands what is mutable?
It can be changed.
We can change the elements.
Right. Data 0, 0, 0. Right, you can change the contents of it. Okay, now
Is it possible to change the first three elements of the first row of the first element together at the same time? You showed for one particular component of that one, right?
right. So you want to change all of them, huh?
First row, yeah, for the first element only.
First row.
Yeah, I mean the 17, 15, 17 should be replaced by 9, 9, 9, 1, 1, 1, 2, 2, 2, like that, for example.
Achha. Like this you're saying?
Oh, can you show the output just?
Yeah. I'll show it here. Okay. Just a second. Fine.
Oh, okay.
Okay. Then you have understood, right? You can, of course, a lot of things. I mean, you can do everything. It's quite flexible. So more or less, whatever you generally need, this guy should provide you that. Okay. Let's do a few more shape-related activities. And so shape is a very important aspect. So like data we have. So if you want to know what is the dimension, like you do shape, it will tell you it's a 3x3 matrix. Understood, right? 3x3x3 cube. Okay. You need dave.ndim. It will tell you number of dimensions here, which is apparently 3 in this case, right? And if you data.size, it will tell you the total number of elements here, of course, 27. Clear?
Yeah.
Okay. And the important thing to know here is we have, let me execute this guy one more. Okay, we can change the shape, and this is very important understanding. Okay, so what are you doing here? 2 to 20, and we have say I'll make it say 525, right? Of course, that is not possible. So 8, 64, yeah. So if I make it 64, okay, 8x8. Okay, so if I do data, it's a 8x8 data matrix it generates. What we can do is you can do data.reshape. Okay, you can change it here. You want to change 32 to 2, 32. It just change it. What it did, it created 2 rows of 32 elements. As long as you maintain the total number of size same, you can keep changing such shapes. Fine, right?
Yeah.
Okay, so this is reshape utility. Understood? You can change into more, you can add more dimension also here, like 2, 2, 2, 4. What is it? 8, 4 is 32 into 2, right? So it will change it into this shape, right? Understood, right?
Yeah.
So you do a shape, it will tell you shape of the object. Clear? Okay, now a question. Suppose I do like this. Okay, this is a question. If you understood this, you understood the entire thing. uh, Suppose I'm doing random dot in random. You are generating numbers between 1 and 100. How much numbers you are generating? You are generating size 10, say. Okay, so you have this data. Okay, now if I do this dot reshape, how is this different than the, what is the dimension of this guy now? What is the dimension of E? Any idea? What is the dimension of E? What is the shape of E?
One by one.
10.
Yeah, shape of E is 10 cross 1 actually. So that means it is 10 rows with one element. Sorry, if I dump this is the shape and the number of dimension is of course 2. If I do this is very important understanding here. What are you doing? You are converting one dimensional data into rows
10.
of data. Okay, this is different. What happens when I do this? D dot reshape. Okay, 1 comma 10. It is converting 1 row and 10 columns. F is 1 row and 10 columns. Understood, right?
Hello.
Yeah, clear?
Are you writing something or what? You're writing something?
Yeah, you're not able to see?
Yeah.
The last line is F.
No. Whatever you think. Actually, last line what I'm visible is that is also not clear. E equal to D minus reshape 10 comma 1. That is last line I'm getting. After that, I'm not able to. It is not visible for me.
Acha, wait. Fine, huh? So it might be some resolution problem.
Should I need to change or?
How about you? How about others?
Yeah, I can see that. I can see that.
You can see till F, right?
I can see everything. Yes.
Okay. Maybe you can increase the resolution of your screen, Venkatesh.
Is there? Where can I change?
In view options, you can go for the original size, or you can go for that.
Option.
Exaggerated size.
An original size.
You might have clicked the original size. That's why.
Yeah.
You can click on the fit to window, then you'll be able to see that.
Fit to window. Yes.
Okay.
Now visible, but actually some stuff is not clear. E minus, E minus D. There is some blur in the text.
Are you joined via this app or browser?
Yeah, via app.
Oh no, joined by a browser.
Okay.
Even I joined by app only. But
oh, okay. Somebody I hear this concern. Okay. Okay. Maybe I'll actually can try doing in the something in the next class here. Is it fine now?
It's purely. Yes. Now it is okay.
Now it is okay. You can see till F, huh?
Yeah, I can see.
Okay. So yeah, this is about reshape, and you can see what is this doing. This is one row with all the elements. This is different from this. Understand this line?
Yeah, d dot reshape 1 comma 10. It will gives one row with 10 columns.
Right. That means it is two dimensional. So if you print here f dot endim, it will be two dimension here. Okay.
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 Which one is two dimensional? Sorry, think,
This
should
guy.
be like that should be a 1 by 10, right? Like one row and 10 columns.
Right. So what is one row
So
10 columns? It is a row vector. You can imagine, right?
row vector, yes.
So it is a two dimensional.
Okay, okay. Yeah, understood.
Okay. And whereas in the beginning when I did, it is just 10 elements here.
Uh-huh.
Okay. Okay. So this was about reshaping shape and all that. Okay. One more thing about reshaping is how can you add more dimension? Say you have f, right? Okay. F like this. D. This is D here. You want to add one dimension. So what you can do is np dot new axis. If you do this, it will return you it will add one more dimension. Okay.
One thing, 1 minute, 1 minute. Actually, I've changed to fit to window. Then also other things. Have you written something over there in the screen?
Yeah.
But that is not visible for me.
I'm a little surprised.
Actually, I'm also getting surprised why it is getting because currently my screen is in full mode.
Okay, so you can see this part of it now. D is equal to D.
No, actually, currently your time is showing up, and only you printed that array is printed till that I'm getting visible. Other than that, it is not visible for me.
Acha, maybe there is some issue. I don't know. So how about you? It's fine all, Vineet?
For me, it is fine. I can see everything.
Okay.
I see. I think